So today we're going to learn about logarithms. Logarithms are the opposite of exponentials, just as subtraction is the opposite of addition, and division is the opposite of multiplication. Logs undo exponentials. Technically speaking, logs are the inverses of exponentials. In all practical terms, I found it useful to think of logs as this relationship here that's in this box that we're getting ready to look at. So over here on the left-hand side, we have an exponential equation. And over here on the right-hand side, we have a logarithm equation. These two equations are equivalent, okay? It's very useful to be able to go back and forth from these two different forms, from an exponential form to a logarithm form. So that's what we're going to be focusing on today. Going back and forth from an exponential equation to a logarithm equation. So I want to examine this a little more in detail. So let's look down here. So I just changed some of the letters, but it's still the same thing here. We got this exponential equation, n is equal to b raised to the p power. And then we got this logarithm equation, p is equal to log base b of n. Well, the base of your exponential equation is also the base of your logarithm. Okay, the b stands for the base. And what the exponential equation is, that n value, that's going to be the number that you're taking the log of. And then your exponent is what the logarithm is equal to. So just study this little pattern. All right, so before we do this next example, I want to go over the definition of a logarithm. So this is important that you write down in your notes. So the definition starts off like this. It says, suppose b is greater than 0 and b is not equal to 1. For some number n, where n is greater than 0, there is a number p such that the log base b of n is equal to p if and only if this statement is true. B raised to the p power is equal to n. So there's some important things we should examine here. Your base has to be greater than 0, and it can't be equal to 1. That's important to remember. We're going to be using it throughout the whole chapter. The base has to be greater than 0 and not equal to 1. Also, your n value, the number that you're taking the log of, also has to be greater than 0. So if a number is greater than 0, basically that just means it's a positive number. So your base got to be a positive number, and what you're taking the log of has to be a positive number. All right, so now let's look at an example here. Let's see, here's example 1. So these problems are already solved. Bear with me here. This board is not working for me for some reason. Try this again. It's not letting me choose. Okay. So I'm just gonna move this down and rewrite our property here. If we have n is equal to b to the p power, remember that's equivalent to this statement. P is equal to the log base b of n. So on example 1, we get 10 squared equals 100. The direction says change the exponential equation to a logarithm equation. So this equation is a true statement. If you take 10 and square it, that's equal to 100. It's already solved. We're doing no math here. All we're doing is practicing going from one form to the other form. So it's written as an exponential equation. We want to rewrite it as a logarithm equation. All right, so the base of your exponential equation is going to be the base of your logarithm. So we're going to write this as log base 10. Okay? Now we just got to fill in these blanks. We got to fill in this blank and this blank over here. All right, so what is the 2 here? The 2 is my p value. That's my exponential. That's what your logarithm equals. So I'll put a 2 here. So I got log base 10 of what? Well, that's my n value. That's what you're taking the logarithm of. So what what your exponent equals in your exponential equation, that's what you're taking the log of. So 10 squared equals 100, written as a logarithm equation, will be log base 10 of 100 is equal to 2. All right, so take a minute, try B and C. I just want you to rewrite it as a logarithm equation. So for B, you should have got log base 2 of 8 is equal to 3. Log base 2 of 8 is equal to 3. Again, the base of your exponential equation is the base of your logarithm equation. So how would we rewrite C? That would be log base 16 of 4 is equal to 1/2. So again, we didn't do any math here. We're just rewriting it from an exponential equation to a logarithm equation. All right, so now let's see how we can actually solve some logarithms. So let's look at example 2. It says find each of the following logarithms. We want to know what does log base 2 of 32 equals. Again, let's just write up here our property here. So far, we only have I've only taught you one thing about logarithms. Now, one thing is how to change it from an exponential equation to a logarithm equation. So remember, these two equations are equivalent equations. So on example 1, we practiced from going from exponential to logarithm. So on example 2, we're going to go in the reverse order. To help us solve this, we're going to go from a logarithm equation to a exponential equation. I want to know what does the log base 2 of 32 equals. Since I don't know what it equals, I'm just going to say it equals x. I have no clue what log base 2 of 32 is. So I'm just going to set it equal to x. Okay? So now, basically, it's written as a logarithm equation. We want to convert it to an exponential equation. So this process I use, I call it like the circle of life or something. So what you're going to do is you're going to start with your base. As you guys remember that song, it's all about the base. That's what we're going to start with. So my base of my logarithm is 2. So that's going to be my base of my exponential equation. And then I'm going to do this thing called the circle of life. So I'm going to go 2 is my base. So I'm going to go 2 raised to the x power is equal to 32. I got 2 to the x power is equal to 32. So now what we want to do is solve this equation. This is an exponential equation. We should know how to solve this. We have done problems like this in the past. So here's what we want to do. Since my variable is located up in the exponent, I'm going to rewrite the right-hand side, the 32, as a power with the same base. So I get 2 to the x. Well, 32 is what? That's 2 to the 5th power. So here's what we got. We got 2 powers equal to each other that have the same base. So what you can do is you can set the exponents equal to each other. So the only way the left side equals the right side is if they have the same exponent, since they have the same base. So x will equal 5. What that means is log base 2 of 32 is 5. So now we know how to solve a logarithm. So we want to do the next one here. Example 2b, we're going to start it off the same way. We want to find what log base 2/3 of 9/4 is. So I'm just going to set this equal to x, since I don't know what it is. And again, it's all about the base. So we're going to start with our base. And we're going to do the circle of life. So we're going to go 2/3 to the x power is equal to 9/4. And then I'm going to do it just like I did A. I'm going to rewrite both sides as powers. And I want both sides to have the same base. Okay? What I really like about logarithms is because it reviews everything we have learned this year. We got 2/3 to the x power. Well, 9/4 is what? 3/2 squared. Okay? But we got both sides written as powers, but they don't have the same base. Okay? But there's a little trick we can do. If you think back to the last chapter, we have a to the negative n, that's equal to 1 over a to the n. So what we could do is, I could rewrite either side with a negative exponent. What that would do is that would flip my base. So I'm just going to leave 2/3, leave this side as 2/3 to the x power. But what I could do is I could rewrite the right-hand side as 2/3 to the negative 2nd power. I'll show you why this works over here to the left here. So if we got 2/3 to the negative 2nd power, well, we can take the negative 2, the exponent on the outside, and multiply by all the exponents on the inside. We'll get 2 to the negative 2nd over 3 to the negative 2nd. And remember, you can't have a negative exponent. So what's going to happen is both of these powers here are going to switch spots. So when I rewrite this, I'll get 3 to the 2nd over 2 to the 2nd, which is 9/4. If you look at our equation, that's what we started with. So what does x equal? X equals negative 2. So the log base 2/3 of 9/4 is negative 2. All right, questions? All right, I'm going to skip over some examples because we're going to do those tomorrow. So I'm skipping over example 3 for now. I'm going to look at example 4 here. I'm going to look at example 4C. This is like what we've just been doing. I want you to find the log base 3 of 81. What is log base 3 of 81? So again, since we don't know what log base 3 of 81 is, let's set it equal to x. And now, let's use that one property that I showed you so far. Those two equations, how they're equivalent. So let's rewrite this as an exponential equation. So we're going to go 3 to the x power is equal to 81. So since my variable is up in my exponent, I'm going to rewrite both sides as a power with base 3. So 81 is what? 3 to the 4th power. So what does x equal? X equals 4. So that means log base 3 of 81 is 4. This is what you're going to be doing on today's assignment. I want to see you rewriting. I don't want you to do it in your head. Eventually, we will get to the point where you can do it in your head. But for today's assignment, I want to see you rewriting it as an exponential equation and solving it. So let's look at D. We got log base 1/3 of 27. So again, our first step is to set that equal to x. So we're going to go 1/3. When I have a fraction, I always like to put it in parentheses. I'm taking 1/3 to the x power, and that's equal to 27. So I want to rewrite both sides as a power with the same base. Well, hopefully you realize 27 is a perfect cube, so you can rewrite 27 as 3 to the 3rd power. So we got both sides written as powers, but they have different bases. But you should notice the bases are reciprocals of each other. 1/3 and 3 are reciprocals. So whenever that's the case, what you can do is you can use that negative exponent rule to get the bases to match up. So I'm just going to leave this as 1/3 to the x power, but I'm going to rewrite 27 as 1/3 to the negative 3 power. Making that exponent negative flips the base. Because if 3 was written as a fraction, it would be 3 over 1. A negative exponent just basically flips your base, takes the reciprocal over. So, what does x equal? X is equal to negative 3. So the log base 1/3 of 27 is negative 3. All right, a couple more examples. Let's look at E here. We got log base 9 of 1. Log base 9 of 1. Again, first step is just set that equal to x. Do your circle of life. So you go 9 to the x power is equal to 1. Let's rewrite both sides as powers. We'll get 9 to the x is equal to 1. Well, there's another rule that you have to remember. Remember back when Mr. Stuckey was teaching you guys, he said anything to the 0 power is 1. A to the 0 power is 1. So I could take 1 and rewrite 1 as 9 to the 0 power. So now they have the same base. So x is 0. So log base 9 of 1 is 0. That means 9 to the 0 power is 1. All right, let's look at F here. For F, we got log base 8 of 4. What is log base 8 of 4? So set I equal to x. And then let's go start with our base of our logarithm. That's going to be the base of your exponential equation. So you're going to go 8 to the x power is equal to 4. Now we want to rewrite both sides as powers of the same base. Well, 4 is what? 2 squared. Can you rewrite 8 as a power of 2? You can. 8 is 2 to the third power. So what we can do over here is we can replace the 8 with 2 to the third. But the 8 was being raised to the x power. So 2 to the third is being raised to the x power. So we got this, 2 to the quantity 2 to the third raised to the x power is equal to 2 squared. So before we can set the exponents equal to each other, we got to get rid of our parentheses. So we're going to use another exponent rule. When you get a power raised to a power, remember you multiply your exponents. So we're going to get 2 to the 3x is equal to 2 to the second power. So now, since I have base 2 here and base 2 here, and they're equal to each other, the only way these two equations these two powers can be equal is if their exponents are equal to each other. So we can set 3x equal to 2. And then divide by 3, divide by 3, x is equal to 2/3. So the log base 8 of 4 is 2/3. It's very important that you remember everything we've been working on since the beginning of the year, because you're going to see it all again in this chapter of the logarithms. All right, second to the last example. Let's look at G here. We got the log base 10 of 0.0001. We want to know what that is. So again, let's set that equal to x. And we're going to do the same thing. Start with our base, do the circle of life. We got 10 to the x power is equal to this decimal, 0.0001. Okay? I don't like decimals. So what I'm going to do is I'm going to rewrite this decimal as a fraction. So what is 0.001 as a fraction? Well, that's 1 over 10,000. Okay? So now, let's see if we can rewrite both sides as powers. Well, I'm just going to leave this as 10 to the x power. And I'm going to rewrite the right-hand side as 1 over 10 to what power? 1 over 10 to what power is 1 over 10,000? To the fourth power. And now let's look. Look at our bases. Over here we got base 10. Over here we got the base as 1/10. What are the bases? They're reciprocals. So what do you do to get the bases to match up when the bases are reciprocals? You use the negative exponent rule. So I'm going to leave this as 10 to the x. And then I'm going to change that 4 to a negative 4. And what that does is it flips the base. It changes the base from 1/10 to just 10. So what does x equal? X equals negative 4. So log base 10 of this decimal is negative 4. Right, I want to go back and look at one more example here. This one's going to look difficult, but we can do it the same way. Actually, let's just save this one for tomorrow. I'm going to save this example for tomorrow. So on the assignment, what I want you to do is only 1 through 9. Okay? Tomorrow I'm going to teach you how to do 10 through 21. So do 1 through 9 for tomorrow.